Since inventing the first hard rock tunnel boring machine more than 50 years ago, the Robbins Company has expanded its tunneling capabilities to include soft ground. Today, Robbins provides earth pressure balance machines known as EPBs for projects around the world. Every Robbins EPB is customized to a project's unique requirements, including ground conditions, tunnel alignment, and project location. This video explains how a typical Robbins EPB excavates in soft ground and why they are the tool of choice for contractors worldwide. Robbins earth pressure balance machines range in diameter from 3 to over 14 meters. The front of the tunnel boring machine consists of a rotating cutter head in which cutting tools are mounted. The cutter head is supported by a Robbins main bearing, which has the largest bearing to tunnel diameter ratio in the industry, resulting in superior bearing life. For soft ground excavation, the back-loading cutter head can hold a variety of carbide cutting tools. In mixed ground conditions containing sections of hard rock or boulders, the cutter head is fitted with a combination of carbide tools and single or double disc cutters. As the cutter head turns, the cutting tools make contact with the material to be excavated, known as the face. A unique smooth flow spoke type cutter head design draws more muck from the face with a large opening ratio, resulting in decreased torque and thrust requirements and less abrasive wear on the cutter head structure. Depending on the ground conditions, additives can be injected into the face through multiple points on the cutter head. With additives, the face of the tunnel is more stable and is less likely to collapse during excavation. The additive may consist of foam, polymer, or bentonite. During the excavation process, ground material or muck moves through the cutter head to a mixing chamber. Inside of the chamber, the muck is pressurized and holds the tunnel face. The pressure differential between the chamber and the screw conveyor then draws the muck into the screw conveyor. As this happens, the muck's pressure is reduced from ground pressure to atmospheric pressure. The depth of the tunnel, the ground material, and the water level above the tunnel determine the ground pressure. In the case of lower ground pressure, only one screw conveyor may be needed. For projects with high ground pressure, Robbins installs 2 screw conveyors in order to bring down the pressure smoothly. After passing through the screw conveyors, the muck can be transferred to an open belt conveyor and then removed from the tunnel by muck cars or a conveyor system. The ability to balance the earth pressure is essential in order to safely and efficiently excavate the tunnel face. A TBM operator can control the pressure in the chamber continuously. To raise pressure, the operator can either increase the machine's rate of advance or decrease the rotation of the screw conveyor. To lower pressure, the operator does the opposite, either decrease the rate of advance or increase the rotation of the screw conveyor. The EPB cutter head is followed by a shield body. The shield body may be divided into a front and rear section for when the machine requires articulation during curved tunnel drives. During an EPB boring stroke, the cutter head turns and thrust cylinders extend to push the machine forward. These cylinders transfer the thrust to the cutter head by reacting against the tunnel lining. After each TBM advance, the thrust cylinders retract. Then, another ring of segments is placed by a segment erector, and a new boring stroke begins. Since the cylinders react against the tunnel lining, it is not possible to erect the lining simultaneously while boring. Thus, tunnel boring and tunnel lining erection are sequential operations. Using a process called active articulation, Robbins EPBs can produce tight curves with a radius as small as 3 to 4 times the tunnel diameter. Active articulation allows the thrust to be transferred equally to the entire circumference of the segment ring, eliminating the problem of ring deformation. The articulation occurs between the front section and rear section, which are connected by articulation cylinders. Other EPBs use a process called passive articulation, which places uneven pressure on the rings while steering and causes deformation of segment rings. Proper support of the tunnel walls as the TBM advances is critical to the safe construction of a tunnel heading. As the machine bores, temporary gaps form naturally between the soft ground and the tunnel lining. The boring process also creates a risk of settlement and upheaval at the surface. To stabilize the soil and fill gaps, the process of backfilling is used. Robin's backfilling system utilizes 2 liquids rather than the industry standard 1 liquid to achieve more precise and effective backfilling. The liquids by themselves remain fairly viscous and are combined together in the tail shield where the hardening process begins. The liquid is injected from several points on the machine and flows around the tunnel walls, filling in any gaps and hardening rapidly. The entire process utilizes low-pressure pumps as opposed to concrete pumps, minimizing the risk of ground disturbances. Robin's earth pressure balance machines maintain the highest quality standards in the industry, resulting in rugged machines that create the longest tunnels in any type of soft or mixed ground. Robin's, the most trusted name in tunneling.